We have a Lowrance HDS7 Gen 2 Touch on the bench. Customer complaint is backlight's not working. In fact, I remember the customer texted me some pictures of this and some suggestions how to repair it themselves. There was quite a few toasted components, if I remember, and they ended up just kind of giving up on the repair and said they'd send it in, which is totally fine. We're happy either way to help people or do the repair here. So, okay, problem right off the bat. As soon as I turned the 12-volt power supply on for the unit turned on. So there's more than just backlight going on here. There's other issues on the board. The backlight is indeed not working. I can just barely see the Lowrance logo in there. If you take a light and you shine in, it probably won't come up on camera, but I can see. Yeah, I can see the display in there. So definitely backlight, but also some other issues. Probably, if I had to guess, that MOSFET that controls powering on is probably shorted. But we're going to take this thing apart and check it. Yeah, and here we go. It's the backlight circuit in the board right here. A little toasted. So hopefully we can bring this thing back to life. If this is just totally toasted and there's no repair, especially that that chip right there, we'll have to make a custom backlight for this unit. So all hope isn't lost. We can definitely repair this unit no matter what. We'd prefer to repair the board, but if we can't, we'll just throw a completely custom backlight driver in this board and call it a day. We still have to figure out why the thing powers up by itself. So what we're first going to do is we're going to clean up this area of the board. We're going to clean this all up, remove these three components here. There's a Schottky diode here and two caps. And we're going to see if this thing powers up by itself again. Okay, we'll remove the Schottky diode and the two caps. And it still turns on by itself. Okay. So here is that MOSFET. It's an N-channel MOSFET, 100 volts. So we have an N-channel MOSFET right here, right at 100 volts. We're going to replace that MOSFET, and we're going to see if that solves the problem of this thing automatically turning on when 12 volts is applied. Okay, we replaced that MOSFET. Let's see if this thing still powers on by itself. Alright, that's one problem down. So it is not powering on by itself now. Let's see if we can power it on. Yes, good. Good. Okay, so that problem is fixed. Now let's see what we can do about this backlight mess here. Let's see. Okay, well, it looks like we have a bad backlight controller chip. Let's see what happens here. We're probably going to see some smoke, maybe some sparks here. Let's see. Three, two. It's about 4 amps pumping through that board right there, so that's not good. So you can see right there, there's tons of heat coming off that chip. What we're gonna have to do, and by the way, it took out our MOSFET again. That inrush of current toasted that MOSFET. So we're gonna replace that again. We're just gonna strip the side of the board. We're gonna take the Schottky diode off, the cap, the existing backlight driver, and we're just gonna have to make something custom here. Get right back with you. Okay, let's make sure that this thing doesn't power on by itself. Okay, good. Kind of back to square one again. Okay, so what we're going to do is build a custom backlight driver for this board. We're going to try to use the existing backlight board, backlight LED board the way it is, and just build an actual driver to boost the voltage to the backlight. And we'll get right back. So just a quick update. We spoke to the customer. They want to go ahead with the backlight repair. We're going to build a custom backlight driver here. We are currently milling a custom circuit board, and that's going to handle. In the past, we've made some sort of one-off copper clad boards just with like a Dremel tool and stuff. But since we're getting more and more backlight jobs, we just really quickly designed a backlight PCB, backlight trigger board, I guess you could call it. We're going to mill the first one up. Should be done in about 20 minutes or so, 15-20 minutes. And then we'll populate the board. There's a couple LEDs on there for testing and MOSFET basically. As soon as that's done, we'll get it over here and start putting some components on the board. Okay, the board is milled. It's getting kind of late in the day. It took a little longer than I thought. So probably gonna head out for the afternoon. I might come back to the shop later this evening, later tonight, to finish this up. But here's the board. So we just have to pop this out, tin the pads, solder the components on, mount this to the board, and we should be good to go. Okay, we have our custom backlight trigger board. I guess that's what I'm going to call this. And this is our backlight power supply. So maybe driver and power supply. Doesn't matter. In any case, this is just a custom board we milled real quick. In fact, I'm going to be putting a few batches through just for future jobs. Just have them all pre-made, just so I don't have to put the extra time in when I'm actually doing the repair. Is backlight power supply. So let's see how this thing works. Now, if we're getting our trigger voltage, this should be yellow. If I short these two pins, this should be red before the unit's even on. If there's 12 volts coming into the unit, this is just a test point I made. If I short these, it's red. That means it's getting the 12 volt supply. Which it does not seem to be. Oh, things always work better when you plug them in. So let's plug it in. Now let's see. See if we get the 12 volts. There we go. So our test point tells us we're getting power to the board. 3, 2. There we go. Awesome. Beautiful. So the next test, we got backlight when it powers on. That means our board's receiving a trigger voltage, which is turning on this MOSFET. This MOSFET is basically turning on the power supply here, and that's sending the proper voltage to the backlight. So the next test is, does the backlight turn off when the unit goes off? We're going to test that right now. So keep a close eye on this LED and also the backlight. There we go. Trigger LED's off, backlight's off. Beautiful. Perfect. Okay, so what we're going to do is just permanently mount both boards. What I'm going to do, I'm going to take a little bit of time, not today, but I'm going to redesign this board again. And I'm going to do away with this second board. I'm basically going to design my own boost converter and incorporate that into one single backlight board rather than using a boost converter separately and then a trigger board. So that's in the works. I should probably work on that maybe this evening or tomorrow or something. And then we'll mill these in-house, populate them, and we'll be good to go. So we'll get right back as soon as we have this stuff permanently mounted. Okay, and here we go. We're all installed. Like I said, what I'd like to do is consolidate all this so it's a smaller footprint. Maybe 3D print a bracket in the future or something. But in any case, this unit is ready to go. We notified the customer. They're super, super excited, super happy. If anybody has any fish finders, Lowrance, Hummingbird, Garmin, or any electronics in general, we repair all electronic devices. We do custom projects, one-off things, and also production stuff. You can go to our website. It's www.rudolphrepairs.com. You can email us at rudolphrepairs@gmail.com. If you'd like, you can give us a call, 1-800-517-9101. And I'll see you guys next time.